applications or word problems with inequalities is the topic that we're doing today. We're just going to basically do a few examples. Practicing this stuff is the number one way to get better at it. I'm going to start by giving you 3 general steps for kind of how to approach writing your inequality from all of the words. So let's list the steps in here and then we'll go through it real slow for a few examples. So before you do step 1, obviously you guys know you need to read the problem, circle all the numbers, underline stuff that you think is important, cross stuff out that's not important. So do that part, really analyze the situation. After you've done that, step 1 would be to write an expression. So something like 5x plus 3, okay, does not have an equal sign. Obviously, we're doing inequalities. So write an expression to represent what's going on. Step 2 would then be to write what goes on the other side of the expression, or like the opposite side of the expression from what you wrote in step 1. Now, I'm going to underline this part. Usually what goes on the other side is just a number. Usually, okay, but it isn't always. That's why we use the word usually. So once you've done those 2 things, and obviously in example 1 here, I'll kind of show you what all of that means. But once you've done those 2 things, step 3 is to figure out what kind of sign you have to use. So we're not using an equal sign anymore. We're using inequality signs. So obviously it's going to be a little bit trickier. In my personal opinion, this is the hardest part, deciding whether it's which one of these 4 you're going to use. Okay, so that's the last step. Once you've done that, it's going to look like what it did last time when we were solving inequalities, and then you just solve for your variable. So hopefully from there, you feel like you've got it down. Writing the inequality, though, that's going to be the new part for today. So let's practice a few times. So example 1 says, Johnny wants to spend no more, I'm going to underline that. He wants to spend no more than $500 on a new gaming system and some games. Okay, it's got a good chunk of change there, 500 bucks. Can't spend more than that though. Now, the game console costs $249.99. So he's got to buy the game console and he wants to buy some games. So all of those cost $35 each. I want to figure out what's the possible number of games that Johnny can buy. Okay, so obviously he's got to buy this, and then he's going to buy as many games as possible. So step 1, you want to write an expression to represent the situation. So basically I want to write how much all of this costs. That's going to be like my expression here. So ignore the $500 here. I know that the console costs $249.99. He's going to add on to that $35 for every game. So I'm going to use G. So if I define my variable, G represents the game. Okay, so that's my expression for like his cost, how much he's going to spend here. Now, step 2 says, write what goes on the other side. So obviously I'm going to have 2 different sides to my inequality. This is going to go on one side, and I said usually just a number will sit opposite that on the other side of the sign, and that's happening here, okay? And I want you to make a note that that number that we're usually looking at here is usually a total number. Okay, so you want to look for a total, like how much money this person has, how much they can spend. And that's exactly what this $500 is. That's how much money Johnny has. Okay, so that's the number that's going to sit on the other side. Okay, so if I kind of like start my inequality here for step 3, take the expression that I wrote right away that represents how much he's going to spend. His total amount that he has, I'm going to sit that on the other side, and I'm going to leave some space for the sign, because that's step 3, to figure out which one of my 4 signs I'm going to put in between these things. So you've got to think about it. Now, does Johnny want his actual amount spent, so how much he pays the cashier, does he want that to be more than or less than $500, his target amount? Well, he only has $500, so he cannot spend more than that. His only option is to spend exactly that or less than $500. So here's how I think about it. Where G is on the left side here, that represents how much he's going to spend. This $249.99 plus 35G, this is how much he can spend. Okay, so that has to be less than or it can equal exactly $500 for him to be okay and be able to afford what he's buying. Okay, so that's less than or equal to. So now I've got it all set up, and this is where I'm saying now it looks like what we did last lesson and the lesson before. It's just a two-step inequality, so hopefully this is easy to solve from here. Okay, you can use a calculator. Nobody wants to do all these decimals by hand, so I'm just going to solve for G. Got my little calculator here. Okay, so 35G is less than or equal to 250 and 1 penny, and then I'm going to divide by 35. So let's see what I come up with here. All right, 7.143 blah, 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 blah. Okay, so I'm saying the games that Johnny can afford is less than or equal to 7.143. Okay, now he doesn't have to buy the max amount. He can buy one game. Maybe he doesn't like a lot of the options that the store has and only wants to buy one game. This is why this is an inequality, not an equation. He has options, okay? But I want to figure out, like, how many can he afford at the most if he's trying to max out his money. So this 0.143 of a game, that doesn't make sense. Okay, so I have to round this, you guys. He can either afford 7 or 8 games. Now, when you're doing a problem like this, you cannot just use typical rounding rules all the time. You've got to think about what makes sense in the problem. Can he afford 7 or can he afford 8? Which way do I round this? Well, you could plug it in here for G. So let's say that I decided, all right, maybe I'm going to round up, which most of you probably wouldn't do. But check your answer and see if it makes sense. If you're standing in the store and you're trying to buy 8 games, you're going to go over the $500 that you have and feel real awkward when you go to pay. Okay? You don't have enough money. So Johnny can only afford 7 games. So when I write my answer, I'm going to write it G is less than or equal to 7. Okay, again, I'm not going to say G equals 7 because he doesn't have to buy 7 games. He doesn't have to spend all of his money. He can buy 2, 3, 4, however many he feels, but the max he can buy is 7. Okay, let's do another one. So example 2 says, on a hunting trip, Taylor's goal is for him and his dad to get at least 35 rabbits. Taylor gets on average 3 rabbits per hour, while his dad gets 16 total. Find the possible number of full, so they underline that, that's probably important, full hours Taylor needs to hunt to reach his goal. Okay, follow your steps. I didn't write it as like step by step on this one because that's not realistic. We've got to be able to think without that. But let's think about it. So I'm going to find the possible number of hours. So H is my variable. That's what I'm trying to figure out. How many hours does he need to hunt to reach his goal? So on the left-hand side, I'm going to write an expression to represent the situation. So I've got Taylor and his dad hunting rabbits. Now, Taylor, he gets 3 per hour. I know that per means multiply, so I'm going to multiply 3 times H. So on top of that, that's going to have me add on. His dad just gets 16. Not per hour, he just got 16 rabbits. Okay, now that's kind of like the expression that represents the situation. And on the other side, I'm going to put, we said usually it's just a number, and right here I said look for like a total. So they're wanting to get at least 35 rabbits. I don't know why, but that's how many they want. Dad gets 16, Taylor gets 3 per hour, so I got to figure out how many hours does Taylor have to hunt for them to get at least these 35 rabbits. Okay, so set up either side. Then decide what sign goes in between. So you have to think about it, where the H sits. So the variable side that side represents how many rabbits they're going to end up getting. Okay, and I want this to be at least 35. So I want this to be 36, 37, 38. At the very least, it needs to be 35. So that means it needs to be more than 35, or it can be exactly 35, since 35 is the least. That part is tricky, so you just got to think through it and be real careful. Okay, once this is set up, this should be real easy to solve. And honestly, I'm not even going to write the steps out because you guys should know that you just subtract 16. And then, let's see, I'll write that out. Divide by 3, and it's going to be a decimal, so I got to think a little bit through repeating. So I've got to decide, do they need to hunt for 6 hours or 7? So I decide, do I round it up or I round it down? And don't just think, oh, it's 0.3, so I round down. Word problems kind of go against the rounding rules sometimes. So let's think about it. And if you don't know, well, come back up where H was and plug it in. So a lot of you would say, oh, I round down. Well, how many rabbits does Taylor get if he only hunts for 6 hours? Taylor would get 18. Add on to it 16 that Dad gets. They only get 34 rabbits if they hunt for 6 hours. So that's not the answer. If I hunt for 7... okay, then they get 37, so they've got to hunt for at least 7 hours. So, and it doesn't have to equal 7. They can hunt for way longer than that if they are feeling adventurous. So the hours they hunt has to be greater than, or it can be exactly 7 for them to hit their goal. Okay, on the back, number 3 is a little less complicated as far as like setting it up goes. It's pretty straightforward. So that's the one I want you guys to try. Set up your inequality and then solve it. Now, number 4 is the last one I'm going to do because it's a little bit different. So it says, Sherry started a business designing and selling custom t-shirts. The equipment she needed, and this is good for Sherry. None of that's really important. She's selling t-shirts, great. Now, the equipment that she needs costs $4,700. Okay, so she's got to spend that up front. She also has to buy plain t-shirts for $320 each. So there's a cost. She then sells the t-shirts, so she sells them for $19.99 each. For what number of t-shirts sold would Sherry make a profit? This problem, I don't know if this is familiar to you, but this is kind of like a break-even problem that we did last unit. Okay, so we're not asked when she's going to break even, we're asked when she's making a profit. If you guys remember, so I'm going to make a note, this is like break even. Break even, we did cost equals income. No longer are we doing equations with equal signs, we're doing inequalities. So that's going to come into play when we talk about the profit part at the end. But let's start like we did last time. And let's set it up with the expressions on each side. So I am going to take this break-even idea. If you're talking business like this problem is, you guys, you're always going to set it up like this. Cost on the left, income on the right. So what are Sherry's costs? Well, she spends $4,700, and then on top of that, she has to buy the t-shirts for $320 each. So T is t-shirts. And here's where this class can be really annoying. Maybe it's annoying for a lot of reasons, but if you can't set up a break-even problem, this is going to be really hard to set up. So things kind of build off each other. On the right-hand side, you write how much money Sherry makes off of these t-shirts, and she sells them for $19.99 per t-shirt. So you got to put a T on there. Now, deciding the sign is the last step, step 3 from the front. So think about like when you make profit. Do you want your costs to be bigger or your income to be bigger? Well, if I'm going to profit, obviously I want the money I'm making to be bigger than how much I'm spending. So the income side, that needs to be greater. I do not want the or equal to, because if I had it equal, that would mean I broke even. If your costs equal your income, that's exactly what you've done. You've broken even. I want to be greater because I want to make a profit. So that's the sign I want. Income needs to be bigger, mouth open towards it. Now I just solved this. So let me get the t's together. So 1999 minus 320. And again, hopefully the solving part isn't too bad. And then I just divide. And I'm guessing this is not going to come out nicely. Nope, so I'm going to have to think about rounding. Because I'm pretty sure that Sherry can't sell, excuse me, pretty sure that she can't sell 0.928 blah 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 of a t-shirt. So she's either got to sell 279 or 280 t-shirts to make a profit. So let's think about it here. Now, if you're not sure, you could test it, but I'm pretty sure most of you would decide this correctly. Let's say I do test 279 because I'm not sure. So plug it into the cost side. I'm just plugging it in where T is. If I plug that in there for 279, her costs would be $5,592.80. And if I plugged it into the profit side, she would make $5,577.21. Okay, if she only sells 279 t-shirts, her costs are more expensive than what she's making. So she's not going to make any profit. She's still in the hole because her money out of pocket is more. And I don't think a lot of you would round down, but I'm just trying to show you that you can check your answer to make sure it makes sense. And if you plugged in 280, that would be the first number of t-shirts that she sold where she would make a profit. So I'm going to write 280 here, and I'm going to keep it set up like I had it. So t-shirts, and you need to write the inequality as your answer. Don't just say 280, because hopefully Sherry sells way more than that. Hopefully she just doesn't make a tiny profit. Hopefully she sells like 500 or 1,000 t-shirts and makes a massive profit. So as long as her t-shirts sold is greater than 280, she's going to profit.